Welcome back. Java application landscape is very complex. There are so many frameworks, so many tools, so many things that you can build, and the evolution of microservices and cloud adds in a new layer of complexity. We are frequently asked, how can I become a microservices developer? How can I become a cloud developer? And these learning paths are an answer to that question. In this learning path, we will learn how to become a Java full stack developer. The prerequisite for this specific learning path is that you should know Java. This learning path is recommended for junior Java developers as well as senior Java developers who would want to start learning how to build full stack applications. By the end of this learning path, you would know how to build great REST API and you will know how to build a great full stack front-end application as well. Each of the learning paths will contain details of the frameworks, tools, and also the specifics. They'll contain the details of what you need to learn about each framework, what you need to learn about each tool, and also it will contain the details of how you can go about learning it, what videos you can follow, what courses you can follow to complete this learning path. To be able to complete the Java full stack development learning path, as I said earlier, we would want to build a REST API and also build a front-end full stack application. To build the REST API, you need to know Spring, Spring Boot, and also JPA or Hibernate. Actually, Hibernate is an implementation of JPA. So if you are using Hibernate, you already are making use of JPA actually, and vice versa. You should know how to build a full stack application. We'll be using either ES6 and Angular, actually ES6 and React, or TypeScript and Angular. It's not sufficient if you know the frameworks. You'll also need to know the tools. You need to know the build tools. On the Java side, it's Maven or Gradle. On the JavaScript side, it's NPM. You should also know the IDE. On Java side, you'd be using Eclipse or probably you'd be using IntelliJ. On the full stack side, one of the popular options today is Visual Studio Code. You should also know how to write wonderful unit tests so that your application can be maintained very well over a long period of time. Now, enough overview. Let's get into the details and deep dive into each of these frameworks and discuss what you can learn about each of these frameworks. Let's start with the Spring Framework. Why should you learn Spring Framework and what are the things that you'd want to learn about Spring Framework? Now, why should you learn Spring Framework? How do we build applications typically? Typically, whenever we build applications, we build them into multiple layers. So you have a web layer, you have a business layer, you have a data layer. So this is how we typically build applications, whether it's a full stack application, whether it's a API, whether it's a web application. This is the architecture that we typically use. Before the emergence of Spring Framework, when I have an application like this, the only way to test that application was to deploy the complete application. Let's say I create a var from this application. I need to deploy the var to Tomcat and then I can test everything. Why? Because these layers are tightly coupled with each other. The web layer is tightly coupled with the business layer. The business layer is tightly coupled with the data layer. So it was very difficult to do any kind of unit testing before the emergence of Spring Framework. Spring Framework made all these loosely coupled. I can write a test for a class in the web layer by stubbing out or by using a mock for the data it would get from the business layer. So it was possible to write specific unit tests and test specific chunks of code. Spring brought in this concept of loose coupling which revolutionized the way we build Java applications. And the other important thing about Spring Framework is the modularity of the Spring Framework. The great thing is it's not built as a monolith. It is built in a very, very modular way. So you had a number of components, Spring Core, Spring JDBC, Spring AOP. So you can use any of the components and not use the other components. That was one of the main flexibilities that Spring provided. So if I only want to use a specific JDBC component in a specific project, I can just take the JDBC component and not worry about all the other concepts that Spring brings in. And the other important thing about Spring was the simplicity it brought in. For example, if you talk about EJBs, which were actually ruling the roost when at the time when Spring Framework started coming in, it was very, very complex. If you'd had to do any transaction management or implement anything with EJB1 or EJB2, it was very, very tough. And Spring made it really, really simple. With simple annotations, with simple XML configuration, we were able to do complex things like transaction management. So these are the reasons why you should learn Spring. Spring is one of the top frameworks in the Java world today, and I'm sure it's being used in more than 70 to 80% of the Java projects today. Now, what are the things that you would need to learn about Spring? What are the concepts that are important that you would want to learn about Spring Framework? The most important concept of Spring Framework is dependency injection, or it's also called inversion of control. How does Spring provide this dependency injection framework? It's through something called Bean Factory and also through something called application context. So these are the things that you need to understand when it comes to dependency injection with the Spring framework. You need to also understand the different kinds of dependency injection. There is constructor injection, there is setter injection, and also there is something called field injection. You need to understand all the types of dependency injection and choose the right one for your specific context. The other important thing that you need to understand about Spring Framework are the different Spring annotations. There are a number of annotations like component, repository, there are at service, a wide variety of annotations to define a Spring component or a Spring bean. And if you would want to find all the beans in a specific package, you need to define something called a component scan. So with Spring, you need to learn what is a component and what is a component scan. The other important concepts that you need to learn about Spring Framework are something called CDI, context and dependency injection. After the Spring Framework got successful, there was widespread use of the Spring Framework. The CDI was introduced as a Java EE standard. So CDI is a Java EE standard which defines the different annotations and all that stuff around context and dependency injection. And Spring is actually an implementation of the CDI as well. So you need to understand what is CDI and why is it important. The other important thing that you need to learn about Spring is aspect-oriented programming. When we develop things in layers, there are certain things which are common to all these layers. For example, logging, authentication, authorization, these might be needed by all the layers, and things like that can be implemented using aspect-oriented programming. So you would need to learn Spring AOP. So at a high level, the important things that you need to learn about Spring are related to the dependency injection. You need to learn what is dependency injection, you need to understand what is Bean Factory, application context, you need to understand annotations, component scans, and also you need to understand the two different ways of configuring Spring context. You can use an XML as well as Java. So the preferred approach today is the Java approach. Typically today, most of the projects use Java based annotations to define components, to define component scan and all that stuff. But if you go a couple of years back, XML was the popular option. So you were defining the Spring beans and auto-varying and all that stuff in a XML file. There you go. Those are some of the important things that you would need to learn about Spring. Now that we learned about the Spring framework, Let's now jump into the Spring Boot framework. Spring Boot is one of the most important frameworks that evolved in the last few years. Today, whenever people say microservices in the Java world, it kind of relates to Spring Boot. It became so popular. Now, why did Spring Boot become popular? Thing is, Spring and Spring MVC frameworks were really awesome. However, you had to write thousands of lines of XML to configure something, or thousands of lines of Java code to configure a lot of things. Configure a database, configure a dispatcher servlet, configure a data source, and all that stuff were very tough to configure. And this meant that it used to take a long time, like 15 days, 20 days, to get started with a project, to create a new project, set up the layers, all that stuff. It used to take around 15 days. And this is without considering the non-functional requirements like application configuration, monitoring, and all that stuff. So the setup of a microservice used to take a long time before the emergence of Spring Boot framework. And that's the reason why Spring Boot framework became popular. It made the setup a very easy thing. Now, what are the things you need to learn about Spring Boot? What are the important concepts? The most important concept that you need to learn about Spring Boot is something called auto configuration. What is auto configuration? Let's say you want to develop a web application. All that you need to do is to add Spring MVC dependency into your class path. Spring Boot would automatically configure a dispatcher servlet and it would redirect all the URLs to that. So that's auto configuration. Let's say you'd want to use a database, you'd want to connect to a database. All that you need to do is add a JPA or a Hibernate jar into the class path, and Spring Boot would auto configure a data source for you. If you add an in-memory database, it would automatically configure a data source pointing to the in-memory database. So all this is the magic of auto configuration. Because of auto configuration, the amount of initial configuration that you need to do goes down drastically. The other important features that Spring Boot brings in are faster integration of projects. So if I want to integrate a new project, integrate a new framework into my project, Spring Boot makes it very easy. How does Spring Boot make it very easy? Through something called Spring Boot starter projects. So these starter projects make it very easy to add new features to your projects. If I want to develop a web application or a REST API, all that I need to do is use a starter called web, Spring Boot starter web. If I want to develop a web service, a SOAP-based web service, all that I need to do is to add a starter called Spring Boot starter web service. If I would want to add AOP features, I would need to add Spring Boot starter AOP. If I want to write unit tests, I would need to add Spring Boot starter test. So there are a variety of starter projects, including security. You have a starter data JPA to get started with JPA in your project. So all these starters make it very easy to get started with adding a new framework to your project. The other features which are present in Spring Boot are typically what are considered the non-functional features. So what are these non-functional features? Whenever we talk about an application, it will be deployed to multiple environments, right? You will have a dev environment, a QA environment, a stage environment, a production environment. So whenever you deploy code, it would need to go through all these cycles, and the database you would want to connect to in dev might be different from the database you want to connect to in prod. So you need to store all that configuration information in your property files. Spring Boot makes it very easy to have application configuration through something called profiles. So you can create separate profiles for dev, QA, stage, and production, and you can store the configuration for those environments in those profile files. It makes it very easy to do environment configuration. The other important thing that Spring Boot brings in is simplified deployment. How does it simplify the deployment process? Typically, before the emergence of Spring Boot, the most popular way of deploying web applications was to use WAR files. So if I would want to deploy a WAR file, what do I want? Tomcat. If I would want, or actually it can be Tomcat or any other app server. So it can be WebSphere, WebLogic, whatever you would want. So Tomcat, to run Tomcat, what do you want? You would want Java. To run Java, what do you want? There should be a operating system and also the hardware or the machine that you would want. So to install a WAR file, there are a lot of things that you would need to do. And with Spring Boot, it brings in a concept called embedded servers. What is an embedded server? Example of an embedded server is Tomcat. So what happens is the Tomcat gets embedded into the jar file. So whatever is the output of the project, when you build a project, you get a jar file, and the jar file already contains the Tomcat inbuilt. And that's the reason why with Spring Boot, if you are building a jar file, you don't really need to install Tomcat. You can directly have a jar file and directly run it wherever Java is installed. So all that you need to run your application is Java. So the simplified deployment is very important benefit of Spring Boot. I have worked with a number of applications, number of microservices serving millions of requests which are built as jar files. A lot of people think WAR files are much more stable than jar. Actually, jar files can be as stable as WAR files, and that's why Josh Long says make jar, not WAR. Now, the other important things that Spring Boot brings in is monitoring. How does it bring in monitoring? You can add in something called Spring Boot Actuator. So Actuator helps us in adding monitoring features around our applications. The other thing Spring Boot also helps us to do is to make your development faster by something called developer tools. One of the things that slows developers down a lot is whenever you want to make a change, you need to restart the server. So make a change, stop the server, start the again. Instead of that, if you add developer tools, Spring Boot developer tools into your project, the restart happens automatically. Whenever you make a change and save the file, the restart happens immediately and the change will be visible for you. So if you look at Spring Boot, it really brings in a lot of efficiencies into the Java world. And that's the reason why Spring Boot is the #1 framework, and that's the reason why you should definitely learn Spring Boot in today's world. So the important things that you need to learn about Spring Boot are auto configuration, starter projects, and all the non-functional features that Spring Boot brings in. Now that we talked about Spring Boot, let's get into the world of databases. JPA is one of the most important evolutions in the last few years as far as connecting to a database from a Java application is concerned. Let's see the journey to JPA and what you have to learn in databases and also all the frameworks that Java provides to connect to databases. Let's get started with the basic things around databases. So whenever we talk about a database contains tables. So you need to understand what tables are, what columns are, how data is stored and all that stuff. You need to understand how to write SQL queries around your databases. So that's the basics, right? These are like not related to Java at all. You need to understand table, design and SQL queries. So those are things you would want to learn. The other things that you would want to learn when you would want to build a Java application talking to a database. So what does a Java application contain? A Java application typically contains class files. So you have let's say a course.java file, and in the database, let's say I have a course table. What do we want to do when we do develop an application? We would want to get the data from the table inside the database. So from this table we would want to get the data and we would store it into an object of this course.java file, right? That's what we would want to do typically whenever we do anything in our Java talking with a database. And now how do we do that? The most basic option to do that is something called JDBC. With JDBC, you can write a query. So you can write a query, select star from course where so and so condition, and it would return something called a result set back. You can take the result set and you can write code to take each value, each element from the result set and map it to the value inside the course object. So this is JDBC. The thing about JDBC is to do a simple query. Let's say I have 5 fields in course and I would want to take the data from a course row and put it into here. This simple query would need about 25 lines of code. So 25 lines of code to write a simple query, get the data and populate the bean. And it's a lot of code, especially there were like a lot of checked exceptions, and writing this exception handling code was very like monotonous. You just write the same thing again and again and again. And that's where Spring JDBC came in. So with Spring JDBC, the advantage was you did not need to write the checked exception code, and it also made mapping a result set to the bean easier. So with Spring JDBC, the same thing, you can do it with around, let's say, 5 lines of code. The next evolution was a framework called iBatis. iBatis made it even more easier. All that you need to do is give me a query and give me which object you need to pass, which bean you would want to create. So which class you would want to create the bean for. So you just need to say query and course.class. It would execute the query and it would return an object of this course.class. So it made it very easy for you to do this stuff. So most of the time you just configure a few things in XML and you would write 1 line of code and iBatis would give you the result set back. The next evolutions which happened are JPA, Java Persistence API. Actually, the evolution which happened was Hibernate. So Hibernate brought in a new concept. What happened was these queries that we wrote became really complex. I was working with thousands of I was working with applications which had thousands of queries, and some of these queries were like 1,000 lines of query, and it became unmaintainable after a point in time. All the business logic was not in the business layer but was in the queries, and that's the reason why, that's the time period where Hibernate started becoming more popular, where Hibernate brought in a concept where instead of writing a query, so instead of writing a query to get the result from the course to course.java, what Hibernate does is it would add annotations on course.java to map it to a database table. So in course.java, you will say this course entity. So this course entity maps to a course table. This column maps to this column. So you add something called mappings, entity mapping, and you'll add something called relationships. So you'll define what are the relationships between different entities. One course can have multiple students. A student can have one passport. So all these are like a student can have one passport is a one-to-one relationship. A course can have multiple students is a actually it's a many-to-many relationship because a student can take many courses and a course can have multiple students as well. A course can have multiple reviews. That's an example of one-to-many because a review can only be associated with one course. So you define entities, map them to tables. You'll define inside the entities, you'll define columns and map them to table columns. And you'll also define the relationships between entities. You'll say one-to-many, many-to-many, many-to-one, and all that fun stuff. Once you do these mappings, what Hibernate would do is it would generate the queries for you. If you want to do an update, if you want to do a insert, if you want to get the data, all that you need to do is get the right entities and save them. You don't really need to write queries. All the queries are internally generated by the Hibernate framework. So how does the JPA architecture look? You have your classes and you use JPA magic. So you use JPA magic, and what do we do with the JPA magic? You would map these classes to the tables. So you will map it to the database tables. These classes which are used to map things are called entities. So these are entities and these are mapped using JPA magic to the tables. And Hibernate, once you map them, Hibernate would generate the queries for you automatically. Now, what are the other things that you would want to learn about Hibernate? The other important things that you would want to learn about Hibernate is the concept of entity manager. An entity manager manages the entities. So if you want to save something, delete something, all that is done through the entity manager. You'd want to manage transactions. Transactions are very important when it comes to database. Let's say I have account A and you are transferring amount from account A to B, the initial amount in A, let's say, is 1000 and in B is, let's say, 5000. And I would want to transfer 100 rupees from A to B. One of the ways of doing that is, let's say, let's do it in step 1, step 2. So step 1 is actually to reduce the amount in A. So at the end of step 1, so this is 900 and this is 5000, and after that is to reduce the amount, add the amount to B, right? So this is how we typically do, right? So you would first deduct the amount from A and then add it to B. Now let's say at this particular point in time when it was doing step 2, the transaction failed. Can we leave it in this specific state? Nope, right? 100 rupees has disappeared and that's not good, right? So that's an inconsistent state. What we would want to do is we would want to do the whole thing as a single transaction. If this fails, then everything that happened before has to be rolled back and we have to go back to the previous state. If it fails, we would want to go back to this state, and that is what is called transaction management. And with JPA, with anything to do with the databases, you have to do transaction management very, very well. So there are a lot of things that you would want to learn about transactions. The other things that you would want to do is few queries. Hibernate comes in to eliminate the need for writing queries, but there are certain situations where you have to write queries, and in those situations you would go for something called criteria queries or JPQL. Criteria queries enable you to actually write Java code to generate the queries. So you can actually write Java code and create queries. In JPQL, you'd be able to write something similar to SQL but using the entities. So instead of using the tables, in SQL we will use the tables, but in JPQL we will use the entities. We'll use the classes to write the queries. So these are the two possibilities. You would write queries when you would want to actually join, let's say, a lot of tables. You'd want to perform certain like highly performant activities. In those kind of situations, you'd go for JPQL or criteria query. The other things that you would want to learn are caching and also performance tuning. So you would want to generate queries which are really, really efficient. So you want to make sure that lazy loading and all that kind of stuff are efficiently performed. So you should be good at caching and performance. So at a high level, what we have looked until now are the important things that you would want to learn about JPA. You'd want to learn about classes, JPA magic. You'd want to learn about entity manager, transactions, criteria queries, caching, performance, and all that fun stuff. Now, in the evolution, we started with JDBC, we went to Spring JDBC, we went to IBATIS. After that, we said we went to Hibernate, and JPA is nothing but an interface for the Hibernate. So JPA is a Java EE standard. So once Hibernate became popular, Java EE said, okay, let's create a standard around it, and JPA was the standard they created, and Hibernate is actually now an implementation of JPA. So in projects, typically you would want to use JPA because you would want to be able to switch from Hibernate to any other ORM tool that you would want to use. But typically Hibernate is the thing which is used in 90% of the projects as the ORM tool, object relation mapping tool. Now, the evolution did not stop here. The next step in the evolution is Spring Data JPA. So what happened is, after JPA, we saw that there was a lot of code that you need to write to play with the entity manager. So if you want to save something, you need to say entity manager.save. If you want to delete something, you need to say entity manager.remove or something of that kind. So that kind of a code became like standard. So if you want to play with 10 entities, you need to write 10 files which have very, very similar kind of code. And Spring Data JPA eliminates the need to write that piece of code as well. So if you want to really do operations like add, like delete, insert, update with Spring Data JPA, all that you need to do is you need to create the entity and you need to extend a specific interface, and that's it. With 0 lines of code, with almost like, actually it's not 0, with about 2 to 3 lines of code, you'll be able to easily manage an entity. That's the evolution Spring Data JPA brings in. And the next evolution was Spring Data REST. So Spring Data REST was very, very important thing if you want to quickly prototype something. So you have Spring Data repositories, and Spring Data REST can expose REST APIs around these repositories. All that you need to do is add a couple of annotations and that's it. You'll be able to offer REST APIs around your Spring Data JPA. So if you want to create a REST API around your JPA entities with Spring Data JPA and Data REST, you'll be able to do it with about 5 lines of code. So that's the complete evolution. JDBC, Spring JDBC, IBAT is Hibernate or JPA, Spring Data REST. So one of the important things that you need to understand is the entire evolution, and the amazing thing is this is not difficult. All that you need to do is learn in a methodical way, and you'll be able to get through all these stuff. So there you go. We started with databases, trying to understand what tables, SQL queries and all that stuff. Then we talked about the fact that to be able to get the data from the database, you need to have a Java class and write some JDBC code to get the data from the database and take the result set, take the results out of it and map it to an object. And after that, we looked at JPA in depth, where we talked about all the things that you would want to learn about JPA, and we looked at the other stuff in there as well. Let's now shift our attention to learning web services. How do we learn web services? That's what we would want to talk right now. So whenever we talk about web services, we need to understand why we need web services, right? Earlier, we talked about web applications. We said browser is the one which sends the request and we get a response back from a web application, right? This is how web applications work. Now, let's say this is a Java web application and I would want to talk to it from another application. Let's say I would want to talk to it from another Java application. Let's say there is some logic in here which I would want to reuse. How can I reuse it? One of the options is I can create a jar file. So I can create a jar file and I can share it with the other application and reuse the logic. But what would happen if the logic changes? I would need to again redistribute the jar, and the other application should again rebuild and deploy it. Now, let's say the other application is not Java application, but it's a Python application. From the Python application, can I make use of the jar? Oops, not possible, right? So from the Python application, I cannot make use of the jar. And that's where web services come into picture. With web services, you'd be able to support multiple kinds of applications. That's exactly the problem web services aim to solve. So let's say I have a web service. Let's say I have a Java application and a Python application. So both these applications will be able to talk to this web service and get the data it's offering. Let's say this web service is talking to a database or something, it offers a business logic. The Python application and the Java app can talk to this web service and get the data from there. So let's say this is a to-do app and these are two different to-do applications. Maybe this is a mobile app, this is something else. They want to talk to the web service to get the data. So all that is possible when you use web services. Now let's look at the basics of a web service. The most important thing about web service is built to support machine-to-machine interaction. So the interactions which are typically present are from an application to another application. That's what web services typically support. So these web services can be consumed from a web application, a full stack application, a mobile application, or an IoT application. Anywhere you want to be able to consume this web service. The second thing is it's interoperable. What do you mean by interoperable? It means that it is platform independent, it is language independent. I'll be able to talk to it from a Java application, a Python application, anywhere. There should not be any constraints on where I can use this web service from. The third important thing is web services involve a communication over network. If I take a jar file and make it part of my deployable unit, it's not a web service. It's only a web service when I make a call over HTTP, over queue, or some kind of a network. Only then it can be called a web service. Typically, whenever we talk about web services, there are a couple of things that you need to always decide. What is the format of the request? What is the format of the response? Is it JSON? Is it XML? What is the structure of the request? What is the structure of the response? what should be the elements which are present in there. So all those are some of the complexities that are typically present around web services. These things are defined by using something called a service definition. Service definition will say, okay, I'm going to use XML, this is the format, I'm going to have this structure for the request, this structure for the response. So that's what the service definition allows us to do. Let's now talk about how you can learn REST API. Before we talk about learning REST API, let's understand what REST API is all about. We know how the browser works, right? So on the browser, you send a request and the request goes to a web application, for example, right? So a web app, you send a request and you get a response back. The protocol which is typically used in this is HTTP, and when you actually type a URL in the browser, it sends something called a GET request. The interesting thing is HTTP also supports a wide variety of other requests: GET, PUT, POST, DELETE, and a variety of other stuff. So these are all the methods which are supported by HTTP, and when you build REST API, what you are doing is making use of the HTTP protocol. So REST API is all about making the best use of all the things which are present in HTTP. Making use of the resources, creating good resources, and using these methods to do actions on the resources. The format which is typically used with REST API is JSON. So JSON is much simpler format compared to XML. Like typically JSON's size is much smaller compared to XML. So JSON is the preferred format when it comes to REST API. But it's important to remember that REST API does not enforce any standard on what should be the format. So it can be JSON, it can be XML, whatever format you would want, you can use it to build REST API. The only constraint that REST API puts, the only constraint is that you have to use the best, you have to make the best use of HTTP protocol. Now, whenever we look at building a REST API, what are the features that you would want to build into a REST API? Let's quickly look at them. So you want to learn REST API, what are the features you would want to build? One of the important features is something called HATEOS, Hypermedia as the engine of application state. This is actually like whenever you go to a web page, you do not just see the data. You can also play, like you can have links to play around with the data. You want to edit it, modify it, you want to delete it. You can do all that links. So HATEOS brings that to your REST API. So instead of just returning the data back, when you use HATEOS, you can actually return a few links back, which can help you to perform actions on the resource. The other important thing is documentation. REST API does not have a standard documentation format. So the service definition, there is no standard format. Right now in the last few years, OpenAPI, which is actually Swagger based, is becoming popular. So that's a popular documentation standard. You'd want to learn how to do security, how to build security around your REST API. There are approaches like JWT, JWT, JSON Web Token, which is very popular. A simpler approach is basic authentication, but it is not perfect. The other things that you can learn is how to version your REST API. There are multiple approaches: URL based approach, you have a content negotiation based approach, you also have a header based approach. So these are all the approaches that you can learn to do versioning. And also you'd want to do validation. So you don't want to accept any data without validation. So if a request is coming in, you want to validate it. So all that stuff you would want to learn. The other things that you would want to learn are best practices around REST API. One of the most important REST practices is customer first. So whoever is consuming your API, think about them. Think about what are the resources they would want. Think about how they would consume the services and make it really easy for them. Serve them like the best possible documentation so that they don't have a lot of problems. If they don't have a problems, you should, it's a big win for you. The other thing is to understand something called a Richardson maturity model. So a lot of people say, I'm using REST APIs. I'm using REST in the best format possible. Richardson maturity model helps you to evaluate that. So you can say, I'm at level 0, I'm at level 1, I'm at level 2, I'm at level 3. Now, what is level 0, level 1, level 2, level 3? Level 0 is just use HTTP as transport. So instead of using like any other form of transport, you'd use HTTP. So if you actually take normal SOAP APIs, SOAP REST web services, and offer them over HTTP, they become a REST API as well. So they become REST API at maturity level 0. The next thing is to actually use proper resources. So the next thing is to think about your like the things that you are offering and create proper resources around it. So let's say if I'm building a course platform, I would have resources /courses /students and all that /reviews and all that fun stuff. The second level is to actually use HTTP verbs. So we already looked at HTTP verbs: get, put, post, delete. So if I want to delete a student, I would send a delete request to this specific URL. If I would want to add a new student, I would do a post to the URL. If I would want to get the details, then I would send a get request to /courses. It will get all the courses for me. So the level 2 is to make the best use of HTTP verbs, and level 3 is HETEOS. So earlier we talked about adding links, not just giving the data back, but also adding links and specifying different actions that you can do with the resource. The last and the important standard is enterprise standardization, right? So you are building REST API, you'd want to use same standards across your enterprise. So which level you are at in the Richardson maturity model, which versioning you would use, how do you want to do security, how do you want to do documentation, how do you want to do validation. It's very, very important that you standardize that, and it might be awesome if you can actually build a framework around all that and use that in your enterprise. That would ensure that all the REST APIs that you build in your enterprise are all standardized. So you'll not have any variations in how you implement your REST API. Now let's look at the frameworks. So what are the frameworks that you have to learn to implement REST API? The most popular framework is Spring MVC or Spring REST, or whatever is provided by Spring Boot Starter Web. That's the framework. The other option is JAX WS, actually JAX RS, Java API for XML for REST services. The other option is also to use one of the JAX RS compliant frameworks. Like one of the popular implementations of JAX RS is Jersey. You can use Jersey to build your REST API, or you can use any of the modern microservice frameworks, Quarkus or Micronaut. What I would recommend you to do is to start with Spring MVC and build a REST API. It's very, very important, as I said earlier, to build something. I mean, it's always the focus should be on building something, not just learning the framework, but building this REST API with all the features, making sure that you understand that perfectly. That's how you learn your REST API. So there you go. Those are the important things that are related to REST API. Let's now talk about how you can build full stack applications. Before we can think about building full stack applications, we will need to understand what is a full stack application. Let's look at the architecture of a simple full stack application. How does it look? So you will have a REST API which talks to a database. So you have a database and you have a REST API which talks to the database, and on top of it is your front-end application. So this is nothing but a full stack application. Now, an important question you might be wondering is, why do we need full stack applications, right? Why earlier we were building web applications? Why don't we continue building web applications? Why do we need to go for a full stack applications, right? So one of the important things that happened during the last few decades, or actually last decade or so, is the evolution of new devices. Now you don't access applications just from your laptop or computer. You use your mobile phones. There are also IoT devices which might actually connect to your applications. So you'd want to reuse your business logic across all these applications, and that's what building a full stack application enables us to do. The business logic which is present in the REST API can be reused by all the front-end applications. So this might be a front-end application for your browser, this might be a mobile application, maybe an Android, iPhone application, or this is an IoT application. So this architecture would enable us to reuse a lot of our code. That's the reason why we go for full stack architectures. And now let's talk about the languages which are used to build your front end. What is the language which is typically used to build your front end? The front end is typically built in JavaScript, because that's the only language your browser can understand, right? How can you build your REST API? The REST API, on the other hand, can be built in multiple ways. You can use Java, you can use JavaScript, actually Node.js, and also you can use Python. So those are the different languages that you can use to build your REST API. Now, what are the kinds of databases you can use? You can either use a relational database, which is nothing but something like MySQL, Oracle, MySQL Server, any of those things, or you can even use any of the big data databases like MongoDB and things like that. We talked about the languages. What are the frameworks which are used to develop front-end? The popular front-end frameworks are React, Angular, and Vue.js. So these are the three frameworks which are quite popular to develop your front-end application. And in addition to JavaScript, you would also need to learn something called modern JavaScript, which is ES6. If you look at the old JavaScript that we wrote, we were playing with the DOM. We used jQuery and things like that. But modern JavaScript is much better than the older JavaScript, and ES6 is one of the latest versions of modern JavaScript. There are further versions after these as well, but any version which is ES6 and above is something which I consider as modern JavaScript. They contain really good syntax and really good ways of writing good code. The other important thing you might also learn is TypeScript. So if you would actually want to build an Angular application, you need to use something called TypeScript. TypeScript actually is a layer above JavaScript. It adds typing to JavaScript, and also it adds a number of features like interfaces. For me, ES6 was one of the most important things that revolutionized how you can write code with JavaScript. It introduced a number of features like classes, modules, promises, arrow functions, and a wide variety of things. Now, we understood what a full stack application is. Let's try and focus on React. Let's try and understand what you need to learn about React. The basics of React are very, very important. You need to understand what is a React component. In a React application, you'll have a number of components. If you're building a to-do application, you'll have a login component, logout component, a to-do component, a welcome component, a list to-do component. So React applications are built using components, and each of these components have a number of things. Each of these components have something called JSX. They have something called state. They have something called props. What are all these? Let's look at them. So when we create a component, it's a front-end component, right? It will have a way of showing it. That's what is represented by JSX. So JSX is an extension to JavaScript where you can actually do dynamic stuff. So you can create a specific, you can design the layout of something using JSX. Now, let's say you are actually creating a counter component. Each time you increment the counter component, you would want to show an increasing number. So let's say right now the number which is shown by the counter is 10. That's called the state of the component. Once you click the button again, the counter gets incremented to 11. Next, counter gets incremented to 12, 13, and so on. That's the state of a component. The props of a component are things like initial value of the counter. So let's say I want the counter to start with 5 and I set an initial value to the counter. So that's a property. So in React, each of the component has JSX, how it has to be rendered, state in the sense that it contains what is the current state of that particular component and what are the props that are useful in rendering that specific component. And whenever we build an application, a front-end application, there are a number of typical features that you would want to include into your application. Some of these features are routing. How do I go from one page to another page? Forms. How can I capture data from the user and store it back to the backend? Or how can I get data from the backend and show it on the front-end application? The other important things are, how can you make REST API calls? On the backend, you have REST API. How can I make REST API calls? So these are some of the features that you typically build into your front-end applications, and you'd want to learn how to do that. In React, the basic framework provides only the support for the base components. It does not support routing or forms or REST API. You need to bring in additional components or frameworks to be able to do these things. Now, what are the frameworks that are useful to be able to do that? For routing, the framework is React Router. It's one of the awesome frameworks in React world. So it's a great framework to discuss. The forms, Formic is a great thing to use, and for REST API calls, Axios is a wonderful framework to learn. So you look at this specific thing. These are the important things that you would need to learn when you would build a React application. Now let's learn how to learn Angular. What are the important things that you need to focus on when you are learning Angular? One of the most important things about Angular is the fact that by default, Angular uses a language called TypeScript. As we discussed earlier, TypeScript is an enhancement on top of ES6 or on top of JavaScript, which adds in features like typing, interfaces, and makes it easy for you to write maintainable JavaScript code. So you need to learn the basics of TypeScript. Other than that, you'd want to learn the basics of developing front ends with Angular. You need to understand what is a component. Similar to React, Angular also has this concept called component. Each of these components have a template. How should the component look like? They have a style. Should the button be red? Should the box be yellow? All that kind of styling, CSS. And they contain business logic. How can I get data from the backend? Which element should the data be shown in? So each component has all these three things. So template, style, and code. In Angular, you would also create components for each of these features, right? So login component, logout component, to-do component, list to-do component, and all that fun stuff. Now, when we look at the features that you typically build for Angular application or a front-end application, typically the important features that you would build are forms, REST API calls. You might be having routing, how to go from one page to another page. The awesome thing is all these features are directly built into the Angular framework. So you don't really need to add anything to add these features into your web application. There are two other concepts that you need to understand to make best use of Angular. One is modules and the other one is dependency injection. Just like Spring Framework, Angular also has its own dependency injection capabilities. These dependency injection capabilities are directly built into Angular. You just need to add a few decorators on your classes and the dependency injection would happen automatically. So that is something you want to focus on and learn. And the other important thing that we talked about is modules. The way an Angular application will be built is you'll have an Angular application. Each application will have a number of modules. So 1 to n modules, and each module can contain n number of components. So each component that you would build will actually go into one of the modules. So in Angular, your Angular application is built up of a number of custom modules as well as a number of built-in modules which are provided by Angular. And these modules would contain the components. So when you are learning Angular, these are the very, very important things that you would want to focus on. Now, A very, very important question I'm asked frequently is Angular versus React. What should I learn? Should I learn Angular? Should I learn React? Should I learn Vue? For me, the recommendation right now is go with React, because React is a framework on the way up. I like the way React applications are built. I like the way Angular applications are also built, but comparatively, I have it's a kind of a 60-40 choice, right? It's not a 100-0 choice. It's a 60-40 leaning towards React for me. React, I like the fact that React gives you the flexibility to choose the frameworks. So not a lot of features are directly built in into React, and then like things like routing, things like forms, REST API calls, or for all these you have to bring in additional frameworks, but you have the choice there. On the other hand, Angular is like you get Angular in and you get a lot of features for free. So people who like that approach, Angular might be a preferred one for them. For me, however, React is one of the recommended front-end frameworks. One of the amazing things about React is the performance of React. I love the concept of virtual DOM in React. In React, you have a concept of virtual DOM. Typically, whenever we talk about a browser-based application, we are talking about document object model. And let's say I have a React application in here. What happens is whenever you make changes through a React application, what is getting created is something called a virtual DOM. Whenever we make changes through a React application, we are not actually making changes directly to the DOM. We actually make changes to the virtual DOM, and what happens is the React framework internally compares two instances of virtual DOM. So let's say there is an instance 1 before we made the change, instance 2 after we made the change. React would compare them and then only apply the differences to the actual DOM. That's the reason why React is very, very efficient. And you can also have events from the DOM trigger the app. So a button click, a text box, let's say somebody is going into a text box, going out of a text box, on focus, on blur. All those events would trigger the app, and the app actually would make changes to the virtual DOM, actually creates the virtual DOM, and then the React framework would do the diffs and update the DOM. And that's the reason why React is very, very powerful. React is highly performant. The alternative to Angular and React is Vue.js. Vue.js is also getting very, very popular. It's on the growth path right now as we speak. So that might be some other framework that you might be interested to learn as well. Another important thing that you need to understand about front-end applications is how they are deployed and how they go to the browser, right? So whenever you create a project with Angular or React, you would see that there are a number of JavaScript files you would create. Let's say you might create 100 JavaScript files, 200 JavaScript files. But when actually the application is rendered in the browser, you would see that it would just be one file, one JavaScript file, which would go to the browser. How does that magic happen? The magic happens because of a lot of steps that happen. So you have your front-end code. What would happen after you have the front-end code is something called packaging. After that, there is something called uglification which is done, uglify. After that, there is something called minification which is done. And after that is when you have something ready to be going to the browser. So why are all these important? Because your front-end code actually might have 100 different JavaScript files. You don't want to send each file individually out to the browser. It will be very, very, very slow. That's why you actually package it out. So you'll reduce the number of JavaScript files to 1 or 2 or 3. The next thing you'd want is you don't want others to see your code. When you send the JavaScript package out to the internet, what happens? Anybody can see your code, and that's the reason why you do something called uglification. It would actually replace the variable names. It would do a lot of things to make sure that the code becomes a little difficult to understand. Obviously, anybody who can look at the uglified code, if they spend a lot of time with it, they'll be able to understand what's happening. But we are making it difficult with the uglification process. The next thing we can do is minification, right? This uglified file might be very large. So what we would want to do is we would want to minify it. We would want to make it as small JavaScript file as possible and then send it out to the browser over the network. And the same thing in the case of following the standards, writing unit tests. There are a lot of things that you need to do in your front-end application. And that's where there are a few standard tools to create Angular projects as well as React projects. So you can use something called Create React App to create your React project, and you can use something called Angular CLI to create a Angular project. Once you create a project using either of these two, what would happen is you'll have a project which would meet all the best practices, it will meet all the standards that are present, and it would automatically provide all the features that we are seeing right here. So whenever you are learning Angular or React, you should learn the basics of Angular or basics of React. After that, you should learn how to use these tools, and also you need to understand the basics around full stack application. Last but not the least, the most important things to learn is to become an efficient developer. And to be an efficient developer, you need to know how to build your project. Your project might be having a number of Java files. How do you create a jar file from it? How do you create a var file for it? How do you run the unit tests? All that is part of your build, and the tools which are typically used are Maven and Gradle. You have to learn one of these build tools in depth. The other important thing that you have to learn is unit testing. Whenever we want to write any piece of code, you'd want to write unit tests for it. You'd want to immediately check if there is a problem with the code you are writing. Unit testing makes it very, very easy to check for problems. The amazing thing about unit tests is you can continuously run the unit test in a build, and you'd be able to get the immediate feedback. So typically in projects you have something called continuous integration, where as soon as you commit some code, all the tests would run and it would tell you if something has failed. So unit test will help you to get immediate feedback in case of a failure. And typical frameworks which are used are JUnit for writing the basic unit tests. You can do mocks using Mockito. The other important framework in the unit testing space is something called Spring Unit. The thing is, whenever we talk about applications, you build them in multiple layers. You have a web layer, you have a business layer, you have a data layer. The thing with unit tests is you can write tests separately for a web layer, separately for a business layer, separately for a database layer, and also you can write integration tests combining all these stuff. With Spring Boot starter test, you get all the things you would need to write to be able to write individual tests for each of these layers, and also integration tests for all the layers together. It would be amazing if you can actually learn all that stuff. The last but not the least thing whenever we talk about IDEs, whenever we talk about programming, is your IDE. You'll be spending more than 60% of your time on your IDE, and it's very, very important that you focus and learn your IDE very, very well. Whether it's Eclipse, whether it's IntelliJ, whether it's Visual Studio Code, spend some time and become an expert on the IDE. If there is one thing you would want to take out of this video, that's this. Remember that becoming efficient with your IDE will save you hours and hours of time in your career. Actually, days and days of time in your career when you put it all together. So become an expert at the IDE, become an expert at the build, and become an expert at unit testing. Until now we explored the learning part 2 in depth. We looked at the recommended skills. We talked about the fact that Spring Boot databases with JPI and Hibernate are the recommended skills, along with the JavaScript stuff, ES6, TypeScript, Angular, React. And also we looked at the fact that you would want to learn how to build REST API and build full stack applications. Always focus on building something concrete. It might be looking very, very interesting to learn a new framework, but I'm a great believer that you do not really learn a framework until you have built something with it. So try and build a REST API, try and build a full stack application, try and write a lot of unit tests, and that's how you learn everything very, very fast. As we discussed earlier, the prerequisite is Java programming, and the recommended course path in here, if you do not know the Spring framework at all, then I would recommend you to start with Spring framework, go to Spring Boot, then go to Java Web Services and RESTful API, and then go to one of the full stack courses. If you are already familiar with one of these, like if you are already familiar with Spring or Spring Boot, then I would really recommend you to directly jump into RESTful API and Web Services course and then go into the course on full stack. You can choose whichever full stack you would want. And if you'd want to go in depth with Hibernate and JPA, you have courses down here as well. So these courses would help you to learn Hibernate and JPA in depth and master unit testing as well. Uh, the uh, the choice whether you would want to take all these courses or you'd want to restrict to 2 or 3 of these courses would depend on your specific expertise. The interesting thing is we also have a few preview courses. So these are all free courses which are present in here to help you learn to build web applications like using different frameworks. So JSP serverless, you have Spring MVC, you have Spring Boot, we have an introduction to Spring framework, we have an introduction to JPA and Hibernate, and we have introductions to all the tools in here as well. We also have a video to help you to get you introduced to React and Angular. So these are all free preview courses which are present in here, and once you are done with them, you might want to go for these courses as well. So that's it. That's the full stack Java developer path. There are other learning paths that we are creating in here. You can click that link down there and go and choose any of the learning paths. The interesting thing is the link to this particular video. I mean, this particular learning path is present in the description of this specific video. You can find it and go to here and explore it further. And we also have other learning paths on how to go to cloud, how to learn Kubernetes and Docker, how do you become a microservices developer, and we also have learning paths on how to master AWS. I hope you had an interesting time watching this. Make sure that you're building something concrete, and that's the best way to learn any framework or tool. Keep learning in 28 minutes. I'll see you in another video very soon. I'm sure you had a wonderful time watching this video. A number of times I am asked this question: where do I go from here? What next? There are 4 amazing things that you can do to benefit from the great content that we are creating at in 28 minutes. A number of developers wonder how they can become a full stack developer, a cloud developer, a microservices developer, or a DevOps developer. We have amazing learning path videos to help you understand all these career paths and decide what you want to be. Number 2, this video is part of a series of video called Draw with Ranga, and you can actually download the free PDF containing all the amazing images which we have drawn during these series of videos by registering for a free course. Number 3, you can check out our 500 plus amazing videos that we have created over a period of last few years. These videos are organized into playlists to help you learn Spring, Spring Boot, full stack, microservices, and the cloud. Last but not the least is number 4, check out our course catalog. We have a wide range of courses to help you become an amazing developer. So what's stopping you? Go ahead and keep learning in 28 minutes. If you like this video, make sure that you like and also subscribe to this channel. Until I see you in another in 28 minutes video, here's bye from Ranga at in 28 minutes.